Okay, we have a chord. We have a chord, and we have a perpendicular to that chord, which is going to bisect that chord. So that's going to give us 4 and 4. We also have our distance of 3.6, which is just a distance from the center to the chord. So that's a leg of a right triangle. And then I have this leg of a right triangle, and I have this radius of a right triangle. And the radius is also called x, because all radii in a circle are the same length. So I have a right triangle, and I'm going to use Pythagorean theorem. 3.6 squared plus 4 squared equals x squared. I'm going to square root both sides. X is equal to the square root of 3.6 squared plus 4 squared. 3.6 squared was 12 point something plus 16. 12 plus 16 is 28 point something-ish. So we've got 28-ish. And the square root of 28-ish is, let me go into my calculator here in my head. Actually, I use the calculator on my phone. And I got approximately 5.38. So x is approximately 5.38, which makes sense. It's going to be the biggest side, and it's definitely bigger than both 3.6 and 4. So let's try another one. This time no more calculator. So we're not going to use a calculator on the next one, but we're going to use the same ideas. So the same ideas, same picture, different given information. We've got our perpendicular to our chord, which is going to cut the chord into two congruent parts. I've got this unknown amount here that I'm going to call A, and then I've got 4 right here, and then we've got 6 for the hypotenuse. So A squared plus 4 squared equals 6 squared. So A squared is equal to 36 minus 16, which is 20. I break down 20 because I'm going to square root both sides, and I get 2 times the square root of 5. But I need not just one A, I need 2 of them, because x equals 2a. So I'm going to have to multiply both sides by 2 so I can get 2a. So 2a is x, 2 times 2 is 4 times the square root of 5, and that's what x is equal to. Hopefully that was a nice little visual that I gave you there. Okay, I think it's really time for you to try these two right here. Make sure you've got it. So I'm going to do them, but go ahead and press pause, and when you're ready to check your answer, press play. Okay, so I've got x squared plus 15 squared equals 18 squared. 18 squared is 324. 15 squared is 225. So I'm going to have x squared equals 99. X squared equals 99. I'm going to square root both sides, and then I'm going to break down 99. So x is equal to 99 broken down. 3 goes into 99 33 times. 3 goes into 33 11 times, and I get 3 times the square root of 11. And that's the value of x. Now on this next circle on the right, I've got that same situation going on where I've got my right triangle as part of a chord that's been bisected. So I'm going to say each part of those is a, and then x is equal to 2a. Okay, so the whole thing x is going to equal a plus a, which is 2a. And now I'm going to use my triangle here and Pythagorean theorem. A squared plus 6 squared equals 12 squared. So a squared equals 144 minus 36. 144 minus 36, I believe today is 108. 108.36. Yes, I'm going to go with that. I'm feeling confident. I'm going to square root both sides, and I get A equals 108 broken down. 2 goes into 108 54 times. 2 goes into 54 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. We circle our 3s, we circle our 2s. We have a 6 on the outside with a 3 left over. But I need 2A. So I'm going to multiply both sides by 2 so that I can get 2A, which is also called x. So x is equal to 12 times the square root of 3. And that is the conclusion of our work with diameters that happen to be perpendicular